In this video, we're going to talk about a very useful formula called the combined gas law. The combined gas law expresses the relationship between pressure, volume, and temperature of a fixed amount of gas. The formula looks like this. P1 times V1 divided by T1 equals P2 times V2 divided by T2. So it's kind of like an amalgamation of all the other gas laws that we learned in the previous video, which is combining them all into one. So here's an example problem that would require the combined gas law. 322 liters of hydrogen occupies a volume of 197 liters at STP. If the initial temperature of the hydrogen was 37 degrees Celsius, what was its initial pressure in atmospheres? This is actually a pretty complicated question. So let's start with the combined gas law. And actually, we're always going to start with the combined gas law. I'll talk about why later in this video. But what we need to do is comb through all of the variables in this word problem and figure out what information are they giving us and what information are they actually asking us for. So they say 322 liters of hydrogen occupies a volume of 197 liters at STP. So my initial pressure, or my initial volume, is 322 liters. But it's occupying this other volume, 197 liters, at STP. So my final pressure, or my P2, or my V2, I should say, is 197 liters. What else? They've given us that it's occupying this volume, 197 liters, at STP. So this is going to throw some people. You might plug in all these numbers and realize and wonder that they didn't give you enough. But they actually did. They just didn't give you the number. They gave you the words. They told you that this gas is at standard temperature and pressure. If you don't know what that is, look at the cover of your reference table, one of the first tables. They'll tell you that standard pressure is 101.3 kilopascals or 1 atmosphere. Now I'm going to use atmosphere because they're asking for the initial pressure in atmosphere. So if they're asking for atmospheres in the initial pressure and the final pressure, I should also use atmospheres. So they say at this this volume is at standard temperature and pressure. So my standard pressure is 1 atmospheres. My standard temperature is 273 Kelvin. Or 0 degrees Celsius, but this is a gas law problem, so we need to use Kelvin. Okay, so let's plug in what we need on the left here. So they want to know the initial pressure. So we're solving for P1, and they're saying that this initial temperature was 37 degrees Celsius. So 37 degrees Celsius plus 273 is 310 Kelvin. And again, they want to know its initial pressure, so we're solving for P1 here. Okay, so we've plugged everything in. Now it's time to cross multiply. This can get more complicated with more variables, but it really shouldn't be. If you keep your numbers nice, neat, and organized and use brackets, this should be no problem, the math required in this chapter. Okay, so let's cross multiply. P1 times 322 liters, and we're going to cross multiply this way, times 273 Kelvin. That will be equal to 310 Kelvin times, we're going to cross multiply this way now, 1 atmosphere times 197 liters. Okay, so to isolate our variable P1, we're going to divide both sides by 322 times 273. Now you could do this math and write the number down and divide by that number, or you can just keep it like this. It makes no difference at this point. And we're going to do the same thing on the right. We're going to divide by 322 multiplied by 273. Now on the left, these things will cancel, and I've isolated my variable of P1. On the right, let's look at how the units cancel. Kelvin and Kelvin will cross off, liters and liters will cross off. I'm left with atmospheres, which means I've set it up correctly. Now it's time to punch it in. You do 310 times 1 times 197, enter, divided by, open bracket, 322 times 273, close bracket, enter. Now if you type this all in at once, depending on your calculator, you'll most likely get this incorrect. You need to be really savvy with the brackets here. So you can put everything in brackets, or you can just do the first line on its own. Um, Open bracket 310 times 1 times 197 close bracket divided by open bracket 322 times 273 close bracket enter. Or you can do this whole line enter divided by this line in brackets, whichever way works for you. I've known in the past some students have liked to just do this math. They'll do 310 times 1 times 197, enter, write down that number, 312 or 322 multiplied by 273, enter, write down that number, and then divide them. Now it's doing an extra step and it's going to make you take more time, but at the end of the day, whatever gets you the question right is the method I want you to take to solve this problem correctly. So the other reason the combined gas law is really useful, besides the fact that in some problems you need it because all the variables change, but the other reason it's really valuable is you can turn the combined gas law into the other three, because the combined gas law contains all the other gas laws in it. So if you have a math problem, a gas law problem, and the temperature remains constant, or they don't mention the temperature at all, you just ignore it. If you take away the temperature from the combined gas law, it turns into Boyle's law. If they gave you a problem and they say the temperature remains constant, or they make no mention of the temperature, I'm sorry, the pressure, if the pressure remains constant, you just ignore the pressure. And the new formula becomes Charles' law. Or if in the gas law problem they say the volume remains constant, or they make no mention of the volume, you just get rid of the volume from the formula and it turns into that other guy's law there. So for this reason, this is why on your reference table on table T, they only give you the combined gas law. They don't give you the three gas laws. You need to be able to turn the combined gas law into all the other three. So let's do an example problem here. So this is a gas law question, and it's an unknown type, but we're going to start with the combined gas law, and we're going to turn it into one of the other ones. So here's the question. On hot days, you may notice that potato chip bags inflate even though they have not been opened. If I have a 250 milliliter bag at a temperature of 19 degrees Celsius, and I leave it in my car, which is at a temperature of 60 degrees Celsius, what will the new volume of the bag be? So like all gas law problems, you should start with the combined gas law. And you may notice that nowhere in this question are they mentioning pressure. There's no kilopascals, there's no atmospheres being mentioned here at all. So pressure is remaining constant, so we can ignore it. Now our formula is V1 over T1 equals V2 over T2. So our V1 is 250 milliliters. That's the volume of the bag initially, and it's in a temperature of 19 degrees Celsius. We need to turn that into Kelvin. 19 plus 273 is 292 Kelvin. They want to know the new volume, the V2 of the bag, if the car reaches a temperature of 60 degrees Celsius. So 60 plus 273 is 333. And we're solving for V2 here. We just need to cross multiply. V2 times 292 equals 250 times 333. Divide both sides by 292. And we'll isolate the variable V2. And if you do this correctly, you will get 285 milliliters. So we've turned the combined gas law into Charles' law by just ignoring the fact that pressure was not a variable involved in this question here. So that's how you turn the combined gas law into Charles' law. It could have been turned into Boyle's law just by ignoring temperature if that wasn't a variable, or the other guy's law. Same idea. So in summary here, the combined gas law is a way to predict and describe gas behavior when there's not one variable that is held constant. But you can also turn the combined gas law into the other three gas laws by ignoring the variables in the formula that are held constant. Cross-multiplying can become more difficult when you have more variables, but if you keep everything neat and orderly, it shouldn't be an issue. Also, remember, please use brackets correctly when you're using your calculator. The biggest reason I see kids get these questions wrong is not because the math is hard, but it's because they've punched the numbers in the calculator incorrectly. So you need to use brackets to adhere to the order of operations, or your calculator is going to be doing something different than what you intended. So if you're having any trouble with this, please let me know, and I hope this makes sense.